All right, looking at 11.2, we're looking at rational functions. Rational functions identify, today what we're going to do is we're going to identify excluded values. We're going to identify and use asymptotes to graph rational functions. Okay, what we're looking at here for rational functions is marker y equals p over q, where p and q are both functions. Okay, so it really should be a p of x, a q of x, and we should change this a little bit to a f of x. Okay, and we actually go on to say that q of x is not equal to 0. So this is just function notation is all this is. So the function of x, which we also write that f of x is equal to y. We'll say that all the time. So don't be scared to do that. If you see that f of x is equal to y, it's the same thing. So don't think that it's something different. It's something magical. Okay, so this is a function. This is a function. So all it's saying is we have a function divided by a function. Okay, they won't going to get into this function changing as much. They're going to really focus on this one, the bottom function, the denominator function. They're going to look at that and say, how is that changing? What's that doing to our equation? So they're looking at that and saying, hey, we cannot divide by 0. If we divide by 0, uh-oh, we got a problem. All right, so state the excluded value for each function. So we have y equals 2 over x. Negative. Okay, so what we're looking at is where do we divide by 0? Well, this one's pretty easy. So x cannot equal 0. And that's what we're looking for, is saying that x cannot equal 0. If x equals 0, then we're dividing by 0. It's irrational. Okay, so it's not a rational function at that point. Next one, we have y equals 2 over x plus 1. They just like the 2, I guess. I don't know. This one here, looking at this. This one's not done anything. It's this one right down here. So we can say x plus 1 is equal to 0. So x is equal to negative 1. So x cannot equal negative 1. And you could have looked at that right there and just said, hey, what can I put in there to make it 0 here? So some of them are that easy. They can just kind of look at it. Some of them you actually have to go through and work them out. For example, C. Part C. We have y equals 5 over 4x minus 8. So we're looking at saying, where is this bottom thing going to be to 0? Okay, we can look at it and say, well, I know what it is. X cannot equal 2. Well, I want to double check that though, just make sure I'm right. 4x minus 8 equals 0. 4x equals 8. X equals, divide both sides by 4. 2. Yes, we were right. Okay, so we have that. So x equals 2. So that's where we cannot have. So x cannot equal 2. That would give us a vertical asymptote. That's going to give us a bad number. So that's the number that we're excluding. So it's not rational at that point. Okay, we look at example number 2. If there are x people in the basket of a hot air balloon, the function y equals 20 over x represents the average number of square feet y per person. Graph this function. Wow. Okay. So all they want us to do is they just want us to graph it and say how fast, is this thing going to be down? Is what they're really looking for. So we have y equals 20 over x. We know that we cannot have 0, so that's our vertical asymptote right there. It doesn't really make any sense to really have any negatives either direction. We know that we need to go, I can go by 5s, by 5s. So if I put in 0, I'm not going to get a number, so it's not going to work. If I put in 1, I'm going to get 20, so 1 would be about right there. And there's my 20. I put in 5, I'm going to get 4, right? Because 5 goes into 24 times. Okay, so then if I put in 20, I'm going to get 1. So this thing is going to look like that. Okay, so looking at this, it's going to look like this. It's never going to touch the x. It's never going to touch the y. Those are what we call a vertical asymptote, is the x equals 0. And actually we have x equals 0, and we have another horizontal asymptote at a y equals 0. And that's really what they're trying to focus us on now, is where are we concerned at, what are asymptotes. You might hear this pronounced asymptote, okay? Some people pronounce it that way. I call it asymptote, or asymptote. And so that's really what we're looking at here, and they have a really nice picture of it. We look at the equation, y equals a over x minus b plus c. Okay, looking at this, you notice you got to recognize that minus b. Okay, the reason why is because whenever we solve, we set that equal to 0, so x minus b equals 0, so x equals b. It makes that positive. So that's why it's the opposite of that. So if we look at back at the previous ones, that kind of jumps out at you. A is just how fast is this thing changing? How much damage is this thing doing? Okay, this is just a multiplier really right there. C is how much are we going to shift it up or down? And that's a straightforward variation, and that's why there's a plus there, because this tells me straightforward. If that's 4, I shift everything up 4. If it's minus 4, I shift everything down 4. This is different. Now this one here tells me if I shift it left or right. So I'm going to take this whole thing and I'm going to shift it left or right, b units, but it's going to be the opposite. So remember that equation I just did, that x equals b, because x minus b equals 0. And you add that over. So that's really where it's coming from. Okay, kind of a lot to take in right there. So let's go ahead and apply that. And so if we apply it, we go to the next example. So we're on example 3. We have 2 over x minus 4. So we have this right here. And then what they want us to do is they want to identify the asymptotes of each function and graph the function. So if we're identifying the asymptotes right here, well, we know that x cannot equal 0, right? And then we're shifting it down 4, so y cannot equal 4. Okay, so that's what we're looking at, or negative 4, sorry, negative 4, direct variation. So negative 4, so y, that's where we're looking. So if we graph this, we know what an inverse function looks like, because that's all we're doing is just graphing inverse function. That's that same equation that we had from 11.1. So we have this right here. We know it's the general looks like this and this. But now what we're doing is we have this one here, so we still can't equal 0, but everything's going to be shifted down negative 4. So go 2 different ways. So I have my original function. It's going to look very, very similar to this. It's going to change a little bit because of that 2 up there. But all I'm going to do is come here. And I'm going to say this right there is negative 4. So it's going to do the same thing, but now all of a sudden I just shifted that line up. Okay. I could plot points and get it that way. You know, you put in 1, you get 2 minus 4 is going to be negative 2. You just keep plotting the points, and then you'll kind of see it. Same thing with the next one. Now we have 1 over x plus 1. So what they did here, they just did a vertical shift on us, okay, and they shifted it down. So the next one, what they're looking at is we have, now what we want to see here is, oh, now this is going to be our horizontal shift. So x cannot equal negative 1. Remember, it's the opposite sign there. Y plus 1 equals 0, so y equals negative 1. That's where I'm getting that from. So now this one here, instead of it being a vertical shift, it's a horizontal shift. So I have a vertical asymptote. We'll see that as a dashed line. There. There. And we have a horizontal asymptote, so y cannot equal 0. Okay. So y cannot equal 0. So that didn't do any vertical shift, it just did a horizontal shift. And remember, that is opposite sign. I cannot stress that enough. That's opposite sign. Wherever we're working with multiplication, division, stuff like that, this is usually opposite sign. Anything out there, that's straightforward shifts. Okay, if you have any questions, comments, thoughts, let me know.